So if we go ahead and have our panel members come up. So what I'm hoping to do with this panel is take the discussions from yesterday and broaden them out a little bit and raise them back up to the really to go to the variety, as Melissa pointed out, of personal exposure measurements that we're likely to encounter as an environmental health community, which we know is not a homogeneous community in any way, shape, or form. It's a variety and a myriad of communities that will come together to address these issues. We've talked quite a bit about the gaps and the challenges associated with personal exposure measurements, as you would expect. We are an emerging science, so we wouldn't have everything quite figured out yet. But I'd like to at least begin to have a discussion of what are some of the best ways that we might look to getting to some of these solutions as they pertain to preparing the environmental health community for dealing with this information, for making changes in our structures to accommodate some of this information and some of the new skill sets that are going to be needed both from a technical standpoint and collecting information and from a risk communication standpoint. So to the extent that we can, let's see if we can move a little bit from the conceptual to the concrete. And I know that's a tall order. But just as a reminder, the subtitle of this workshop is both making sense and making use. So we'd like to see if we can cut across both of those aspects. I would also add that part of this discussion is not just about how we might do this, but also about who is needed to do this. And I'll get into that a little bit more in terms of what types of disciplines, what types of people, what types of skill sets we might need to expand or welcome into the environmental health community in order to deal with these topics. So first of all, most of our panel members are returning members, but we do have a new one, Dr. Mary McCord, and I'd like to ask her to briefly introduce herself and talk about the area of research that she comes from.
Thank you. Sorry, how many engineers does it take to turn on the mic? Thanks for having me, Kimberly. I'm really excited to be on the panel. I am trained as a biomedical engineer and also as a textile engineer, and most of my work has been in the area of textiles as both protection for health, maintaining health, protection from different kinds of threats, chemical, biological, and most recently insect vector. I've also worked on sensing and responding textiles that change their structure in response to environmental cues. I've been involved in a project at NC State called ASSIST, which is about putting self-powered environmental and health sensors onto textiles and into textiles and other wearable devices. So I'm coming at this from the perspective of someone who is working with the future students who will be hopefully designing these new monitoring devices, and also from the perspective myself of how to practically engineer these monitoring systems so that they really serve the communities that they're designed for. And that means coming up with context-sensitive solutions. And by context-sensitive, I mean it's not going to be a one-size-fits-all. I mean, from all of our engineering experience, we know you can't design one product and expect it to fit every community. I'm also really deeply engaged in global health, so I would like to see this conversation also take into account communities outside the United States and the practical considerations of how to provide very necessary information for those communities who have quite different concerns, perhaps, than we do here.
Great, thank you. So to sort of get us started, I'm going to very quickly run through some of the areas that occurred to me as possible mechanisms and areas for the development of best practices, some of which came out of yesterday's discussion about challenges and gaps. And just ask the panel to maybe think through some of these and respond to some of these, if you will, with your own thoughts. And particularly if you're seeing any of these kinds of things already occurring in the projects in which you're working. So just some of the areas in which the environmental health community needs to begin to think about this topic. Some of these are structural and particularly perhaps training programs, institutional changes. We talked a little bit yesterday, where does the pressure come from to make these changes? Baruch talked about, everyone should have a team, for risk communication, and it should have all of these people, but, resources are scarce and agendas differ. And so when it comes down to the nuts and bolts of it, where can you apply the pressure to get these institutional changes made so that you're ready to deal with this information, this flood of information that may be passively available or actively pursued through research. Our funding is I think Sima actually mentioned the possibility of grant requirements for contextualization of this information, or we talked about for the drugs, packaging requirements and making sure that that's a requirement that not only do people have access to their measurements and their data, but they have a way to make sense of that information. Are new collaborations going to be required? Certainly, we've talked about citizen science, but also people like economists and engineers and design specialists and the media. We talked about working better with the media, not necessarily just about risk communication, but also about just increasing the media's science literacy and understanding what these sensors do. In addition, people like social media innovators and advertising and marketing specialists, many of our speakers mentioned these products are already on the market. They're already out there. They're already available to consumers. And we talked a lot about validation and making sure that these products are working in the way that they're intended or being used the way they're intended. So do we need new regulatory constraints? Do we, for instance, the Consumer Product Safety Commission, is it something that they would be involved in terms of having an obligation to make sure that the information that people are measuring about themselves is accurate, because they're going to be making health decisions based on this information. Do we need new research paradigms and new policies around IRBs? That are going to be able to deal with the privacy issues and the data sharing issues that we've talked about, and integrated data platforms. And also just as we talked a great bit yesterday, but I'd love to know if there's concrete action being taken on this around standards of exposure and a little bit more than we heard yesterday about methods of validating these new measuring devices and evaluating how well they work. Also, new language and terminology to go along with the risk communication. Very rarely, as you well know, even within a field, do we agree oftentimes on what our terms mean, and we spend a lot of time, arguing about that and using that in different ways. So new formats for communication, and lastly, do we need to create champions, new organizations, new consortia, new groups to deal specifically with the entirety of these issues so that they aren't siloed? Is there a format that we can use for that? And do we need to create influential champions around this topic through demonstration projects that have high visibility or very influential individuals who can help to push the field forward? So that said, I'm going to be quiet and ask our panelists to respond. Those are just some ideas that I had. It's a very broad and open-ended discussion I'm hoping to have. So anyone who'd like to start?
Thank you, Kimberly. That was a lot. And all very good points. I had thought of a couple of responses prior to your list, and I just want to touch on a couple of the things that you said. First, that it came across very clearly yesterday that there are two major gaps that we're facing. One is what I would call the action gap between knowing more about exposures and reducing health risks. And the second is community sense making, that the idea of supporting communities building that leads to better science, both to better citizen science and to better science for citizens, and mechanisms to help improve community sense making so that people have the information they need to make actions that will be effective and help them rather than costly and ineffective. So some of the mechanisms that you talked about seem very promising and have been helpful in other fields, partnerships in particular, partnerships between researchers and students, partnerships between specialists and decision analysts, the kinds of partnerships that Brooke mentioned yesterday to help develop research and devices that are useful to people and that they can understand. But also more standard approaches, institutional approaches such as training of key personnel and education of key personnel, and using things like the forthcoming report from the National Academy of Sciences on the science of science communication to help make people more broadly aware of the importance of thinking about terminology, for example, framing, and understanding the causal thinking of the people you're designing devices or educational materials for. So those are approaches that I thought about. You brought up one other thing that seems very important to me and that we've had troubles dealing with, and this came across in multiple contexts yesterday, and that's IRBs. And Phil, I think, has had the most dramatic experiences with them. But I think all of us who do social science research in particular, but even those who do health research, have had experiences with institutional review boards that are hard to explain and that are costly. I've run into colleagues who have stopped doing research because of IRBs, and I've heard many stories of others who have either had to abandon specific research programs or change their research in ways that made the research much less effective because of IRBs. We have been discussing nationally some changes in IRBs over the last couple of years, but there's a lot more to be done. And the thing that I know of that caused the most discussion was the Illinois white paper a few years ago. But there's been very little movement. If anybody here has ideas about how to make things move on that front, I think that'd be a great topic for a discussion. And we will be discussing it at the Section K of the AAAS meetings coming up in February. So if you have ideas, that would be a great topic.
I think, so just quickly, I think what I had to say follows up well. I see the sensing capabilities falling into two categories. So one is where we're seeking to monitor contaminants or toxins with known detrimental impacts. So your lead, your ozone, the particulate matter. And I think in those cases, absolutely, everything that you said, the answer is yes, we need that. We need to know that when we're telling people there's ozone in the air, lead in the water, that these are the numbers you're being exposed to, and do it in an actionable way. But the other category is the exploratory sensing. And that's where I would be concerned about over-regulating and inhibiting the research that needs to be done to really establish these tools. And I think the example there is the microbiome monitoring that's on the horizon. And Michael, I really enjoyed your talk yesterday. It was really inspiring, and it's an example of that kind of exploratory research that's just opening new doors and new understanding into our exposures. And you know, for example, with the microbiome research, you know, we could learn things about all sorts of diseases, autism, obesity, asthma, but it's still exploratory. We can't tell somebody right now that, well, if you have this microbiome, you're definitely going to have autism. But we need that data. And I think we can tap into just people volunteering, people being interested, just like the folks that wanted to have their genomes sequenced, and just have really careful disclaimers that, you know, we don't necessarily know what this information means. It's exploratory. but still report it back. I mean, I know there's risks that people will make choices, but they already make choices in diet, and you go to the health food store, people buy all sorts of supplements, and we don't necessarily have the science to know exactly what those supplements do, but at the same time, people have that freedom of choice, and people will make decisions, and they can monitor themselves and know if they feel better or not. And I wouldn't want to overregulate and inhibit the science and also people's freedom of choice.
Yeah, maybe just to add on to that. So I agree completely. I think we're talking about different uses here. So when you're talking about a research environment, you want the devices to have some level of, accuracy, but it doesn't have to be necessarily super high quality. This came out yesterday, but we do want to collect the information, and we don't know what most of the information means, but that's why we want to collect it. So we want to collect, in my opinion, as much as possible so that we can make meaningful comparisons and meaningful conclusions from that. And I recognize some of that will actually feed back into community decisions, and those probably need to be validated anyway, even if they're collected in a research format. And then when you get to the individual devices, and you are dealing with known, health related information, I think then you do want the accuracy higher. Who should validate those devices? Well, the companies themselves obviously will have to put out some standards, but you can't really trust them to give proper validations of their own devices. But it'll also be fairly natural for either government agencies or academics to step in. In these new emerging fields, it's very, very common, and this has happened in genomics fields and other fields, people who are academics will just collect all the hot devices that are out there and size them all up and check them out and report back on the specs. And if that's not happening, then I guess I would argue then that's where, the government should step in to make sure that does happen. But it seems to me it has to be an impartial group that would do that evaluation. And then we need some level of accuracy. As far as who gets the information, I think everyone's entitled to this information. And I can't imagine restricting it. I am floored that it does get restricted. As someone who, I'll tell you an interesting anecdote from my study that we're doing, profiling 100 people, they've agreed to make their data public, nearly all of them. Yet I can't return the data back to them unless it's CLIA. Most of the stuff, of course, is not CLIA tests. So this shows the absurdity of the IRB. I can make the data public, but I can't give people their own data. So that's ludicrous. And I pointed this out to them, that I will just point out their data on the public website, and they recognize that would happen, and that's okay. So the whole thing doesn't make any sense, and the way I think we have to fix this, it comes from the conservative nature of medicine in these fields, and I think we have to the world is completely different from the way those folks grew up who are now on IRBs. And so we need just a very different perspective and people with that perspective on these IRBs, and not ones who grew up in a different era who have a very conservative view on this whole situation. I mean, it's pretty ludicrous that you can't have access to your information. Maybe you need to be properly informed about it, which I think you do, but I think everybody should get access to their own information.
I wanted to comment on a couple of things too. Michael, I also enjoyed your presentation very much. I thought it was really interesting the way that you used commercially available monitoring like the Apple Watch, et cetera, your experience with the Lyme disease for diagnosis of your condition. So combining that with some tests that you had run in the doctor's office. And to me, that kind of brought up an interesting issue. I think it was this summer the FDA decided to step away from monitoring a lot of these wearable health devices and claimed that they're basically not being used for treatment, to make treatment decisions for specific diseases, that they're just used for general health and wellness. And I think your example yesterday shows that that's not necessarily the case, that they are sometimes being used to make medical decisions. And I think that puts us in as the people who are working to develop these devices, the people who are marketing these devices, puts them at a level of accountability. And just back to, who should be regulating and monitoring, and I know that's going to be discussed in the next session, but as an engineer, it's also, what kind of accuracy do I need? What is this information going to be used to do? Is it going to be used to just let people know how many steps they're taking, or is it going to, let them know, wow, this is an area you probably shouldn't go and run outside this morning because there's a lot of particulate matter? Or is it going to be used alone or in combination with something else to make health decisions? Other issues that I think have to be addressed are effects on mental health of this information. I haven't really heard that. It's mostly been discussion about, decisions about physical health, but I think a lot of this information and its effect on your mental health when you know that you're being exposed and you're very powerless to make any decisions to change your situation, how does that affect you? I'm also wondering, at what point should we really be engaging the medical community much more substantially in these discussions about, the road, the path forward? So those are the thoughts that I have.
Great, thanks. In responding to that, I'm thinking about some of the things that you raised. I'm very interested in hearing from those of you who are, well, first of all, working in areas with students and with training. Are you bringing these topics into training curricula? Do you see that at all, or do you have recommendations for the best way to do that? In my experience, it's often very difficult to, curricula are very full, particularly you hear about, med students and others, they can't cram one more module into it. And so it's very difficult to get new concepts, particularly when they might be around risk communication or things that are seen as a little bit outside of their direct research training or medical training. So are any of you engaged in bringing issues around personal exposures into training curricula?
So I do that a lot with my group in a number of ways. In fact, just a couple weeks ago, we did a training session for 30 speech-language pathologists and 30 speech-language pathology grad students. And we did a pre- and post-test of environmental health knowledge, and then had 4 of us do a presentation of material that they could share with people when they do home visits, because home visitors are, they have great access to people. They're trusted, and they could really help out there. And we were happy to find that there was a positive increase in environmental health knowledge on the part of those providers. It's work that we have been doing also with physicians. I think it is hard to cram that material in, but I think there's a lot of continuing education work that we can do. In terms of training in general, one of the nice things about the NIHS Center programs is that they have various kinds of research translation cores and training cores that really push this. So they make that communication and that approach very central. In our Superfund research program, we actually do train a lot of the students and the postdocs in this kind of work. The communication work, the participatory research. I have a training program with just not our trainees, but with other students as well, where we have them actually take part in this report back work. They do interviews, they do coding, they help design materials, and they come up with creative ways to do it. So one graduate student currently has designed, instead of reporting back just on paper, on T-shirts. So every participant gets a T-shirt with their data. And they can wear it and show it around to other people. She's also designed what she calls the big bar chart, where there are life-size 3D charts that show your body burden. You stand next to that, and then you move from one to the other. So I think if we can develop more creative approaches like that, we can get more people involved. I think it's a really central thing for our students. And in part, it's also a matter of how do we integrate social science and environmental health science, which is the main thing that I see myself as doing. And along those lines, I would put a pitch in for a couple of special issues of journals. One that's just come out, it's from New Solutions, And it's a result of a conference that we held with an NIHS conference grant in May of 2015. And there's another special issue of environmental sociology on an exposure conference that was held at Drexel about a year and a half ago as well. So these are places where you could read about some actual tangible practices that have been done. And some of the articles in that New Solution issue are actually authored by NIHS people. Sima Fin, who's here with us today, is the author of one, along with Gwen Coleman. Christy Pettibone also has one. A number of the NIHS programs are highlighted in there. So they show you how, in very practical ways, we're able to do this work with, not just with our students and our postdocs, but with our scientists, because the research translation approach really should and does require that the scientists are doing that research translation all the time.
Yeah, maybe just add possibly a different perspective to this. You know, my own view is that this is on the cusp of being a very hot area. We can now do genomes, and there's a huge interest now in genes by environment, as this group knows, and it's just starting to boom. And this whole wearable, portable space is only a few years old when, at a practical level, I know it goes further back, and I probably just made somebody mad here, but, and so it's just emerging, and as soon as you start showing utility, as soon as these, you know, mine's one Lyme disease story, but actually we can do it now for lots of inflammation responses. As soon as a few of these papers get out, people, you know, it generates a lot of interest in the field. It will spread naturally as soon as it goes into the news, and so it'll get communicated that way. I think as far as training, it is true that, you know, what are we talking about training? We're talking about training engineers. We're talking about training bioinformatics folks. It's a fairly diverse set of folks, and there is some activity in this area. You know, the B2K program is funding a number of training things. One of them at Stanford is specifically on wearables. And so that's mostly bioinformatics based. I can tell you though, speaking from my lab, and I'm not trained in this area at all, as you probably know, a lot of people are joining my lab to do wearables now because it's a cool topic and you start matching up with genes and this sort of thing. And I'm sure Chirag can probably cite a very similar situation. So I think, you know, these fields evolve kind of naturally, and we'll be clunky at it at first, as all new fields are, and that's part of the growing process. But I think we'll wind up training, you know, hot fields draw smart people, leads to more hot stuff, and it'll, you see the whole thing just snowballing naturally. As far as community stuff, maybe we should save that for a separate, I have thoughts there, but we'll do that separately.
Yeah, I was going to agree that this is a really hot area and that student training is going to be essential in everything that you talked about, Phil. And I just wanted to add, at Virginia Tech, one of the things that we emphasize in our training is the ethics and trying to train the students in working directly with communities and listening, building that empathy and listening, understanding what they want. And then for sure the report back, you know, they spend hours on the phone with citizens, and most times it's the citizens that are doing most of the talking and they're listening, but, you know, understanding what their concerns are. And I think the more we can build those kinds of connections with us as scientists and real people in the community, the better off we're all going to be.
I wanted to add to at NC State as well, echoing exactly what Amy said, that we do ask the students to develop context-sensitive solutions, engage with communities, do an actual needs assessment with those communities. Again, no one size fits all. I think this is such an outstanding area. It's such a transdisciplinary area. It is a really great opportunity to bring a wide variety of disciplines together to sort of chart out the path for not just what is the research going to look like, but what is the academic program that evolves from this going to look like. So very proactively to sit down and say, how are we going to train the future, the students who are going to work on this in the future?
I think you actually just sort of teed up my next question, which was sort of going from one end of the spectrum to another, from the student and training end to the consumer and the industry end, where the folks who are actually making these and marketing them and selling them. And I'd like to hear from you all, in your experience, are these groups talking to each other? We know there's some research obviously involved in getting a product to market, but are there, in terms of, I think what I'm hearing you guys say is the need to build a community of practice sort of around this issue. And certainly we're familiar with, the end of it that involves, academic programs and training and students. But on the other end, there's industry and there is marketing, and there are real products, and there's economics associated with that. And are these groups talking to each other? And if not, how, are there benefits to having that happen, and how do you best see that taking place?
I can't speak to the companies that are marketing these devices, but I could speak to another interesting approach. I mentioned yesterday my colleague Sarah Wiley, who does this hydrogen sulfide testing using silver nitrate from photo paper. She founded a group called Public Lab. Full name is Public Laboratory for Open Technology and Science, and they're very well known for balloon mapping. They got their start after the Gulf oil spill, doing that, and they've got a big open source approach, a platform of everybody puts together new devices, very inexpensive crowdsourced devices. Technology is all open, it's all out there on a website. People take the stuff, they tinker, they hack with it, they come up with new developments, and everything gets posted and shared. So I think the reason I mention that is because the ethos here is an ethos of sharing, of not having everything patented, but really of a whole different approach to these monitors. Now, these are, again, low-cost, community-based monitors. But the idea here is that they're shared, the material is shared, the technology is all open and available for people to do what they want. So that's not going to be the same as what the manufacturers of these devices do, but I think hopefully they will also look at this ethos of that shared approach.
Actually, go ahead, Michael.
Yeah, I mean, I can't imagine how much companies are going to share this because, they have to make money and they have proprietary products. So I don't know how much they can share. They're always eager to work with academics, of course, because we help promote their products if something good comes out of it. I think how much do we want them to decide all this? Well, I don't know. I think this is where, again, maybe these meetings where people compare products, or if they are going to have health information, there should be standards, and then again, government or academics should review this sort of thing. I would argue, as a way of setting that up. I think the area, though, where I see the big gap is getting the information and sharing the information, so from the information side. And for us, that was very clunky to do. In fact, the way we picked one of the devices, I guess I shouldn't promote any of them, is because they were willing to work with us to collect this information and get it back to us, which turned out not to be trivial, getting it all back, getting in the right format and things. And now it's getting a little more comfortable, and groups realize this is a way to actually promote their products. So Apple now has, a sharing mechanism that didn't exist when we started, and Fitbit now has ways of doing this as well. So I think it's becoming a part of the platform. I would argue it's still a bit clunky as to how to do this, and so I think better mechanisms for sharing information, letting people display their information, understanding what they're sharing is important, because in the end, I don't think it's just going to be, adding one type of data. I think when you start adding GPS and this other sort of data, there are privacy issues. And people will still be willing to share it, but I think you have to inform them what the possible outcomes are. So I think we should be very open-eyed about that. I do think we need to collect more health information, just so this doesn't get lost from this panel, that goes with the other kinds of information we're collecting at a personal level, because I think that's where the ultimate real value of this is. So I know that's a little orthogonal to the current discussion, but I do think collecting that information with any other kind of information will be very, very valuable. If we can get clinical information, again, will maximize our impact. So, a few of my thoughts.
I kind of wish we had maybe Gabrielle and Michael from yesterday here to talk about AirBeam and SpecSense and what their view is on some of these questions. But I just want to draw an analogy with some of the discussions we've been having. We have a facility for disaster research, disaster response research that we just got awarded at the UW, and we've been having these discussions about drone data. So the facility is supposed to provide instrumentation for people to use to go out and collect data after disasters and to promote research. And one of our main aims is to actually be truly interdisciplinary, to try to start incorporating social and behavioral data as well, not just building data and data on what's happened with the physics of the area and that kind of thing. So, and the problem is, with the drone data, you run into all the same issues. The privacy issues, issues of who has the right to collect the data, and then these issues of how you, the format that the data come in, you get scads of data, and if they're not usable immediately, then you can't combine them with the other data you're collecting. So we're running into all these issues, and there's some discussions already about whether drone data are just, for some research, is just out of the question because of some of the ethical and privacy issues, as well as the technical issues of using the data. So the facility is going to try to actually offer pre-processing of the data to make data equally shareable across different kinds of disciplines and useful in different kinds of modeling efforts. And also, there's a discussion of about contracting and partnering with agencies or organizations who already have state-level agreements to use to collect drone data on the part of state governments or that kind of thing. So there's a lot of thought going into now about these kinds of institutional arrangements to make it possible for people to actually collect data that new technologies have made useful, combine the data with other kinds of data, and then use it for modeling and simulation to be able to be predictive in the future. And so this kind of thinking needs to go on in this domain as well.
And I think we have to make a really concerted effort to make sure that we do equitably collect this data, and questions about, access, actually equitable access to these monitoring devices. From the presentation yesterday on Habitat Map or the spec, obviously it was hard to get it into particular communities. I can imagine that there's going to be similar difficulties with personal wearable monitors. We have to make sure that as we approach the big research questions, we get these devices to all types of people.
Yeah, Gary Miller from Emory. One area that I have a little concern about is the field of health is proceeding separately from everything we're talking about, and it shouldn't be. And when you think about like teaching and training opportunities, that would be a great place for that collaboration because they shouldn't be going in different directions. They should be together. On this device thing, what I keep coming back to is I really think it would be great for NIHS to have a call for contracts to systematically test these devices, put all the data online, all the specifications, the interoperability, no recommendations, just the data with very clear testing so people could say, okay, I'm looking for a device that has this sort of range. I can go on there and look at this data that was tested systematically, but it's done as a contract, so it's just put up there, shared right away, and then there'd be a place you could at least refer to. But otherwise, I don't see anyone else taking that effort to do that if it's not some sort of grant mechanism. But that way you could say, oh, we're doing this study, and we refer back to this table on how these things were done. So,
The right agency for that would be NIST, of course. That's just really what they like to do. Yeah. So, should probably put it on the radar.
Which actually was something I'm interested in hearing your thoughts on. Who should take the lead on this? And maybe it's not, just one who, and that gets back to a mechanism of how do you build a community of practice. But someone has to kind of push the field forward, and we have this research, but we know that on the other end, the consumer market is, they're going to go without us. Whether we go or not, they're going to go on their own. And so what do you see as the best, sort of convening mechanism? It's not just a a need to communicate to the end users, but even within the community itself, how do we best, I don't know, Phil, about the training that you did, is that something that you've made available to others to make use of that curricula, or how do you see us best communicating within the environmental health community about these issues, other than just having meetings? And
Well, I think I mentioned yesterday that we put together a handbook on reporting back environmental health data to people based on years of doing this. So that was for us one major way of getting that material out there. And as I said before, we train our students and postdocs in how to do that. But I think the other place to look at is not just the monitors, but I think I mentioned yesterday that we, in our collaboration with Silent Spring Institute, have this Detox Me Action Kit where it's urine sampling. Right now the cost is about $300 per person, testing for 10 contaminants. That's all going to be aggregated into a large database. I think the crowdsourcing approach there is great because even if people can't afford it, like small groups can pitch in together. 10 people put in $30 each. One person takes it. It becomes a discussion issue for their local group. We put out some proposals to funders to actually underwrite the cost of this so that we can get it into the hands of low-income people who would not otherwise think about this. And if community groups who organize around those populations want to take this on, that really gets it out much further. All this is to say, I think we shouldn't only be talking about devices. We should be talking about crowdsourced biomonitoring because there's a lot of other information that we need to get that we're not going to get from primarily the air monitors. They're advanced. A lot of people are doing them. We've got definitive knowledge. We have Clean Air Act. We have criteria air pollutants. We have regulatory reasons for wanting to know this. And I think we need to focus now on the stuff that's less known. And that's why I think the crowdsourced biomonitoring is a great way to do that. So, we would be a platform for getting that and aggregating and sharing tons of that information.
okay, we have a question or comment from the web. This is from Phil. Whoever Phil. I think public education is critical. Non-scientists and scientists need to know about risks, real versus perceived, and what the numbers mean. Not every spike on a meter is bad for all people. Compiling data with medical genetic risks would help. So do any of you want to respond to the public education need?
I think the public education is something that always goes out with the reporting back. We never report data to people unless we also provide exposure reduction information. We never provide any information about breast milk contaminants without giving information from pro-lactation groups. We never scare people. We always give them hope and confidence. So I think that is a whole different way of approaching it. The education and the science really are hand in hand. And I should say that people are actually not panicked by this kind of data, which is one of the things the IRBs, when they reject this, they say, you're going to scare people. And the idea behind IRBs is to make sure people aren't harmed. The other way of looking at that is if you don't share information with them that they should know that you're harming them.
But also at the same time, are there times when you should say, maybe you should talk to your doctor about this, just like all the other information that's shared on the internet when people are trying to seek a diagnosis or understand how something is affecting them. I mean, how much information do you share when you know that somebody is being heavily exposed before you say, maybe you should seek medical care for this?
So absolutely, public education is essential here, and it's also the big challenge, and I think it was mentioned, working with the media, getting these science stories out there. That's more broad dissemination, but where the rubber hits the road, I think, as Phil pointed out, is working with the communities that you're working with. And An example in Flint is we've worked with a group, Healthy Babies, Bright Futures, and what they do is, when folks want to get their homes tested for lead, they'll send them kits, but it's not just, here's a kit, here's the data, okay, have fun. It's, they've got web apps where these people are enrolled, and so they can get regular updates about lead and other toxins. They have a hotline that people can call to understand the results and to help develop a plan for remediation to actually do something actionable. So I think that's one model, and I think that it can work in other dimensions as well.
So
Yeah, Gary Ginsberg, Connecticut. I know that we're talking a lot about personal exposures and monitoring of such, but especially Michael's talk yesterday about some of the health-oriented biomarkers clinically relevant, for example, your pre-diabetic condition, would be, obviously you showed the temporal nature of that and how on an individual level we could start making sense of that kind of data, but when you go back out to a population level, is that kind of information too noisy to think about trying to get population statistics for, ranges and percentiles and understand where you are on some curve and think about putting into an epidemiology test, framework, or is this just too noisy to consider on the population level?
Well, it's a great question. I think the answer is when you're making multiple measurements on the same person, then the noise goes away. If things are, also is it technical noise or biological noise? The technical noise, I think, is easy to control for, and I think that's probably not going to be an issue in anything we're talking about at this workshop, at the level we want to make decisions anyway. But the biological noise, sure, things bounce around, probably because of what you eat and things and such. But I personally think that because you're making multiple measurements, I know my baseline incredibly well. And I will argue that that could be true of every single person in this room if they did what I did, not that necessarily want to. But if you did, you would know your baseline very well. I know exactly what a banana does to my sugar levels. I know that for every single food I eat, actually. And that can and probably will be true of the future for all of you, whether you like it or not. There are easy ways to measure all this stuff. And my own view is that this will ultimately be like your car, which has 400 sensors on it. You don't know any of them probably or where they are, except you probably know they're kind of in the brakes somewhere. And that's the extent of it. And you just see the lights go on when you need to. And I predict that that's at some level what's going to happen here in the health arena and in the exposome arena. That is your iPhone will be marching along like normal until it starts glowing or buzzing or something, and then that's when you'll take notice. And so I think that's where we're going to go, but I think then it's a matter of setting your personal baseline. So I know I drifted from your question, but I think you can do this on an individual level, and that is the goal, quite frankly. It's to understand everybody's individual baseline and what risk factors will put them into the bad health zone. And so I think that's certainly where I would like to see the field go. And it'll take a long time to get there, and it's going to take a lot of people and a lot of data. But this whole we have too much data stuff and how do we analyze it, that really isn't an issue, quite frankly. There's a zillion people out there who really want to get their hands on these kinds of data. So there's no shortage of eager beavers ready to analyze any data we throw at them, including, I'm talking about, petabytes of data. People will analyze that because they're excited about this sort of stuff. And so I think we can get these personal profiles on millions of people. There's something like, I think we've crossed, I'm not sure if it's 100,000 or a million, I think it's 1 million genomes now that have been sequenced if you count exomes. So soon there'll be 1 million, other profiles, medical records. There's a Million Veterans Project to sequence 1 million genomes, and that's going to have 1 million electronic health records. It's almost a crime. Well, some of them will have, because of the vets, they will have some exposure information. But wouldn't it be great if we had 1 million exposures with those 1 million genomes, with the 1 million health records? We would be so incredibly well off with data, we could probably make some real decisions at a personal level with that kind of information. So this data is coming, and we should figure out. Gary's comment was very interesting. It is true that this group should be partnering more with the medical group. It's sort of happening, but it's very clunky, and there aren't specialized meetings. I think all I have to do is put the groups together in meetings, and hate to say it, nothing stimulates people to work together better than money. So if you launch some RFAs with some collaborative, health and environment type initiatives, you'll probably get some pretty smart people all working together with some pretty cool outcomes. So.
Yeah, just a real quick follow-up comment for the health scientists to be able to conclude that as a general rule that Lyme will create inflammation which worsens prediabetes. We're going to need more than an N of one. We're going to need to figure out how to combine all those individual temporal tracks into a bigger picture.
Absolutely. What I can tell you right now, because I didn't tell you the whole story, is that we can pick up with these wearables people's inflammation responses. So it's not just Lyme. Lyme really stands out because it's persists. So if you look at my tracking, but I've been sick 4 times with this device. Actually, once I didn't know it, I picked it up with the device afterwards when I was analyzing the data. My CRP levels were high, actually, and I discovered my heart rate and skin temperature was elevated at that time. So in fact, I had something going on. I didn't know it. So now some people say that's a problem with these devices. You're going to pick up things that you don't want to know about. I don't fall into that category. I'd rather know than not know it. But anyway, the point is we can pick up every one of my inflammations and now several other people's in our study with these devices. So I think it's a general inflammation marker that we can pick up.
Great. Other side of the room?
John Balbus with NIEHS. So I'm kind of grappling with this conflict between the cool and the meaningful, with the difference between this incredible solipsistic deep dive into oneself and the equity issues. And, Flint didn't come about because people weren't wearing wearable LED sensors to show the lead. It came about because of a systematic public health failure to know what was going on in the community, and a lot of other things in terms of decision making at a very central level. And so, what we haven't had a discussion, should public health departments have, SWAT exposure teams to go out and be using this, where there are clear equity issues, where there are clear exposures going on, and conversely, this tension between, we're NIEHS, we're focusing on the exposed, and we're realizing that focusing on 1 or 5 or 10 or 20 measurements of a chemical may not be giving the whole picture of risk, and we have to be looking at things in more context. You only do that on kind of an individual basis because everybody's interaction is different. And I'm just wondering, with some of these technologies where we're focusing in on one exposure, a PM monitor, an ozone, and a wearable technology in an individual, do we run the risk also of distracting people from some of the more important exposures in terms of their actions? So cool versus the meaningful.
Anybody want to take that on?
Yes. No, I think one of the issues, well, probably the driving factor in Flint, is that the public health agencies, it wasn't in their interest to recognize the problem with the lead in the water because they had made a mistake. So I guess the very basic answer is yes, the public health agencies, first of all, we need to make sure that the incentives are there and that we recognize that this kind of failure can occur and that they do their basic job to monitor these contaminants and report it to the public. But yes, it would be great if there's some inspiration there to have this kind of public health SWAT team and, have an eye on these contaminants and move in and do something.
And would you see them, I'm not exactly sure if John was saying that there would be an effort to incorporate these sensors out in the community, and that would be what would alert the public health?
Yeah, I think, that's a good point. There's really an opportunity for citizen science that's been lost. So in Flint, people saw that their water was orange. And, they knew something was wrong. They didn't need a fancy sensor. And so I think we need some culture change to embrace that. And an example is that in the transportation realm, they tap into citizen science to alert them of potholes and all sorts of problems. And so there are examples. I think it's San Francisco that the mayor there uses. I might not be correct, but there are other cities that use this kind of citizen science to get that information from the public and act on it.
So one practice might be actually educating the public that to the multi-purpose use of these things, that they can get personal data and it can be used to inform their officials. Let's take another question.
I would also make the point that sometimes citizen science can find things that traditional agencies can't. If we go back to another waterway in Brooklyn, the Gowanus Canal, public lab people there used a heat sensor in the water to pick up releases from an outlet that nobody knew was there because it looked like it had been closed for a long time, and EPA didn't know that there was anything coming out, but very simple, inexpensive piece of equipment did that. So I think there's a lot of general surveillance of that sort that people can do, particularly in areas of known contamination, particularly around nuclear sites or around power plants that are discharging heated water into waterways that they aren't permitted to be doing. Another example, I think, if we go back to, if we think of ourselves as doing environmental public health, one of the core things that public health always did was surveillance. And that was population surveillance, looking for population health. So one thing I'm really concerned with right now, for instance, are PFASs. And we have through EPA the UCMR, the Unregulated Contaminant Monitoring Program. And we've got data that it's not regulatory, but we've got a lot of reporting from water systems about this. What if we are forcing those agencies to take action and to very quickly switch people's water sources so that they aren't hooked into contaminated water from what we now know are over 600 military sites that are full of PFASs. So those kinds of examples where, again, we're shifting the whole curve, not just the individuals, and we're taking seriously that very initial idea of public health, surveilling for the population's health overall. We can protect so many more people with one action if we switch one water system off contaminated water than if we do a lot of individual monitoring. So I'm not opposed to doing all the individual monitoring. I think it's great, but we have to keep going back to that population level work.
You should.
Okay. Yeah, my name is Yu Xiaxuan from NIHS. Well, I was kind of want to follow the previous discussion about, how to make use of the emerging capabilities in the epidemiological setting or the precision medicine setting, if you will. If I'm an epidemiologist, which I'm not, I want to get a better handle on the environmental exposures, but I have a limited budget. So I can think about 2 ways to go, which already being discussed actually. One way is to recruit a small group of people, couple of hundred maybe, do the multi-omic analysis in a longitudinal way. So, Mike's presentation already showed you can, how powerful that is to find meaningful and explainable findings. But I have the same question or concern is about, how generalizable of these findings will be when you consider the genetic diversity and all sorts of things in the general population. The other way to go is to kind of, elucidated by Edmund Cito and also Phil, to use kind of low-cost sensors to give more people, give access to more of the sensor to more people, and also utilize other like a crowdsourcing, like the habitat map. If you doing research in the New York area, or other regulatory monitor data, and using some mathematical modeling to combine all those data together, you're not going to get as accurate as maybe you're using kind of high-end monitors, but you get a kind of finer scale modeling and estimate of personal exposure. So but for this, as I said, since the data is going to have more measuring error and you're going to have more noise, but you cover the bigger population. I mean, it's being discussed already there. I don't want to, beat a dead horse, but I do want to hear, what's more thoughts about, compare the two, what's advantage and disadvantage, and maybe there's a possibility to combine the two somehow.
So thank you for that comment. Do you want to respond? Sure.
I guess I can comment on that. Yeah, I'm a believer in both for all the reasons that have been alluded to at the meeting. I mean, we do a deep dive on people because I don't know what all the markers are for certain kinds of disease and things, and I'm hoping that the deep dive will reveal useful markers for lots of things. And I can tell you already we have some very interesting metabolites. Some come from the host, some from the microbiome, that now tell us we think we have to validate the equivalent of something called an SSPG assay, which is about a $2,000 test that takes 6 hours, and it's hard to get people to do it. And if I can do a simple analyte measure that does that, well, that's a good thing. So what we're doing is mostly discovery-based science, I would argue, with this deep dive. And from that, I hope to get useful markers that can be applied to a broader group. And then certainly if you want to look, at large groups as a whole, you have to do these low-cost things. And certainly, targeted analytes are one way to go for particulates and I guess for this group to cover a lot of space, both geographically and personal space. So I think you can do both. And at some level, looking at this from other kinds of projects we've been involved in, you can collect a lot of information both ways and then try and impute some of the things in between. So it's not perfect by any means, but it will help. So the bottom line is you get two different kinds of information. They're both very useful.
Hi, I'm Rich Callen from EPA. I just wanted to share some information and also just ask a question. So in terms of what I had mentioned yesterday, actually EPA has the Air Sensor Toolbox for citizen scientists, researchers, and developers. And as part of that, there's actually some data on evaluation of emerging air pollution sensor performance. There are evaluations of 12 PM sensors and 13 gas phase sensors within that, and a lot of other information publicly available in the toolbox that you might want to check that out. Also, as I mentioned yesterday, there's the South Coast Air Quality Monitoring District in California. They have the AQ spec. It's called the Air Quality Sensor Performance Evaluation Center, and they've evaluated a bunch of sensors, and they post their protocols, how they do the evaluations, and a lot of data as well that's available publicly. Also, the Air Pollution Monitoring for Communities grants. As I mentioned, we had 6 grants that we awarded recently through the Office of Research and Development at EPA. The field sites for those communities are Pittsburgh, Chicago, Hawaii, Denver, Colorado, California, 2 communities in North, Middle, and Southern California, and Washington State as well. And I'd be happy, and I put literature about all of these things on the table outside, and you're welcome to ask me. I have some other copies as well. And there's also a press release about the Air Pollution Monitoring for Communities grants, which Edmund Cito is part of, one of the groups at UW doing some work with that. So, and I think in terms of all of this work that's going on, I guess I was thinking about how can people collaborate better. I think that's one of the issues because, and I wanted to also mention EPA has the Smart City Air Challenge, which was announced, that closed on October 28th. And those awards will be announced either in December or early 2017. And that will be going to 2 communities around the country who will be, they're required to deploy 250 to 500 sensors, air quality sensors in a network. And the awards are fairly small in terms of the costs, $40,000. But they were also asked to partner. So partner possibly with manufacturers, partner with other community groups or institutions. And so that, when those awards are announced, it should be interesting to see how that works out as well. But in terms of collaboration, I guess the question would be, how can we encourage all these different groups and and manufacturers and institutions to collaborate with each other.
Sure.
Just wanted to do a follow-up. I'd be curious to know if you've involved social scientists in those requirements, and if there's interdisciplinary work being done to talk about how the information is going to be reported back to the communities and used.
Well, in terms of the air pollution monitoring for communities grants, it was required that they do a lot of collaboration with the communities. I'm not sure exactly. I'd have to look at the grant specifically to see if social scientists are involved in each individual one. But there's a lot of, so basically the requirements for these grants was that they answer certain questions about, for instance, how accurate and reliable the sensors are that are used by the public. What is the quality of the data that the sensors produce? How can the sensors be used by communities to monitor air pollution exposure? And how can the information help communities and individuals understand and reduce harmful air pollution exposures? So a lot of these projects are very much in collaboration with the communities and using CBPR or other types of community outreach and engagement principles.
Just a quick follow-up. I mean, Phil Center is really laudable in the sense that they do both this deep, if we take a parallel to the sensor data, if we take about a parallel with regard to community sense-making and understanding, the research that they've done includes these sort of deep dives into individual conceptualizations of what's going on and thinking about what to do and how to do it, along with more survey data and sort of responses to simpler questions. And so this sort of broader sweep about what's going on. We need both more depth and systematic depth in looking at how people make sense of these kinds of information, as well as broader, more representative samples and survey samples of how communities can make use of this kinds of information. It's very clear that with limited budgets, you can only do so much of each, and so you need the complementarities on the social and behavioral side as well.
We have a few minutes left, and I want to pose one final question, not to preempt our next session, but hopefully to tee it up a little bit, which is we've talked about, we've mentioned the digital divide, which of course separates certain individuals and communities from information and access to information than others. And then Michael alluded to something that interests me, that I think about, which I might call the privacy divide, which is attitudes about privacy, and it's somewhat generational, but it's also dependent and related to the digital divide, as we know, because the more that people use technologies, the more comfortable they tend to become, and the less concerned they are about sharing data. So I'm just sort of interested if each of you could respond briefly in terms of the work that you do. Are these concepts that you're dealing with or addressing or encountering, and how important do you think they're going to be going forward? Yeah, I'm going to start on this end, if that's okay. We're going this way, sorry.
Just say that in my own work, the IRB is always really concerned about privacy, and I have yet to encounter individuals who are concerned about it.
Nice and succinct. I think that the general ethics here is, I call this post-Belmont ethics, because instead of just protecting individuals, we're also protecting communities. And when communities want this data, they want to share it. And that's been our experience. One of the biomonitoring studies that we went back and studied after the fact to find out what the researchers and participants on IRBs thought, we were really amazed that everybody said, I'd like them to do maps. I'd like the researchers to do maps to show where our homes are in relationship to the contamination from this abandoned mine. So they knew that that would be very identifying. Or if you go back, starting with the very beginning of the advocacy biomonitoring with the Environmental Working Group, Pollution Within Us, and dozens of others since then by that group, the World Wildlife Fund, many others, the Is It In Us group, the Commonweal group in Bolinas, California. People are putting their data online with their photographs. In the original EWG group, they did a mock-up of the periodic table where instead of having, let's say, the noble gases here, you had the PCBs, you had the dioxins, you had the furans, and you would mouse over a participant's face and it would light up with what was their body burden. So I think people in this era are saying that of course, it's an opt-in thing. You're not going to do this if people don't want to do it. But there's such an incredible ethics now of sharing this data and going public with it, and people clamoring to be part of those projects. So yes, we always have to be sensitive to concerns about that. But we also have to make sure that we don't regulate it so that it's hard to do.
I think it's really important here to distinguish between sharing exposure data and, levels in communities versus sharing personal health data.
Yeah, generally our experience has been that people want the data and they want it in a timely manner, not a year later. So, we've had to move pretty quick to get data to people. I think yesterday it was mentioned that, there is this community concern that can emerge that, your neighbor wants their data and they want to post it online and they want to map it, but I don't want my property value brought down. I don't know how common that concern is. We haven't encountered it, but obviously it's something that has to be considered.
I guess I'm somewhat agreeing with everyone else in that I can't imagine not sharing it as someone who puts literally half a petabyte of data out there of myself. So, and my own view is that if the government's going to fund it, for most studies, the information should be public. It should be a mandate. Actually, in fact, for this precision medicine initiative involving 1 million people, I would get 1 million volunteers who would agree to make their data public, because as soon as it goes behind closed walls, it's so much harder to work with from the research standpoint. So if it's a research study, I think it really should be open. And for those of you who've ever used dbGaP, it's a real pain. It's, every year you have to renew it. I think actually a lot of people are happy to make their data open. Researchers put stuff in dbGaP because it's a great way to hide your data because it's so hard to get at. So I really think for most government studies, there's a few obviously where you won't get enrollment if you don't, but for most studies we should make it mandatory that the data be open. And I think you'll get plenty of people who volunteer and such. There may be some health situations where you don't want to follow that rule, but as a general rule, I'm a big believer in that.
Final comment, because my light's blinking.
Just to follow up on what Michael said, I would also agree and err on the side of being open, and not just for research. Even though I mentioned the example of where you might be concerned about your property value, at the end of the day, we have to err on the side of protection of public health. And if people are being poisoned, they need to know about it, and you need to find out why and the source and take action.
Excellent. Well, on that very wise note, I would like all of us to give a round of applause and thank our panelists. And I believe we're having a break for how many? 15 minutes? Until 10:45.
Excuse me, could I just take a minute to encourage people to fill out these index cards that we have on the sides of the room and in the back of the room and drop them in the baskets on the back table. There's 3 types of information that we would like on these index cards. They're on the back table now. So we have email address, your email address if you'd like to be added to our list for future workshops. Feedback and comments about the impact of this workshop. I would not encourage you to make comments that about the topics that would be better heard for everybody on the at the mic, but comments about how to make the workshops better and impact of the workshop would be appreciated, and any ideas you have for future workshops. Thank you.